LRDS at number 5. A cube having 2 red faces, 2 blue faces and 2 green faces is given, but where these colors lies on that cube is not known. Whether these colors lies on the opposite side, right, or the same color lies on the adjacent walls. So I don't have the information about the placement of the colors. So we'll take the cases as per the required question asked. And this cube is cut into 216 smaller and identical cubes. So if this cut into 216 smaller cubes, there has to be equal cubes on all the sides. So I can break this 216 into 6 into 6 into 6, right? So this particular cube is basically cut into 216 cubes of 1 centimeter cube. Or if I take this side as 6, this 6 and height as 6, then there are 216 cubes in total of the volume 1 centimeter cube, right? So proceed with the questions. Let us take the question number 1. The number of cubes with both green and red colored faces cannot be more than. So I have to maximize the cubes with red and green color. Okay, so I know that in a cube 2 colors appears on the cubes placed on the edges, right? On the corners you will get 3 colors cube, on the edges you will get 2 colors, and on the face you will get 1 color. So I have to maximize the red and green on the edges. For this, what I will do, I will consider the face to be painted with the same color on the opposite side. So I will take, let's say, this front wall to be red and this back wall to be red, right? Take this as blue, then the opposite side will be blue, this will be green, similarly the upward wall will be green, right? So in this case I will get these edges, this edge, similarly 2 edges in bottom, right? On these all 4 edges I will get red and green both the colors, right? So 6 cubes will be here, 6 will be here, 6 here, 6 here. So 6 into 4, that is 24. So 24 is the maximum number of cubes having both red and green colors. And in my options I have maximum as 24 only. So I need not to check any another case. Answer is option C. Next is, what is the maximum and minimum respective values of number of smaller cubes that have all 3 colors? So the maximum of all 3 colors we will find in this case only. The maximum all 3 colors will lie in the corners. Okay, so this maximum of all 3 occurs in the case when the face which is to be painted with the same color are on opposite faces. So the maximum all three maximum you will get 8, right? So for the minimum case, minimum all 3 colors case, you have to maximize the 2 colored and 1 colored face. So if you check, you will get the minimum of all 3 will occur when the cubes with the faces having the same color are on the adjacent walls. So let us take, this is red, again this wall and this wall, right? Let us the bottom wall as B, this will be blue. Now the upward will be green and the backward wall will be green. Okay, so in this case you will find that this edge will be red and red, right? So you have to find a 3 colors cube, right? 3 colors cube occurs on the corners. This corner, this is red, and this is green. Only 2 colors are available, but you have to check the minimum cubes with all 3 colors, right? So with all 3 colors, consider this corner. On this corner, again you will get this side is blue, this is blue. So you won't get all 3 colors on this corner also. Let us take this corner. On this corner, you will get blue, green and red, right? So there is one cube in which all 3 colors occur. Similarly, on this corner you will get another cube with all 3 colors, right? So minimum of all 3 will be 2 cubes only. The answer for this question will be option C. Let us take the next question. If one of the unpainted faces of all the smaller cubes is painted with red color, then what is the minimum possible number of smaller cubes that have all 3 colors on them, right? So for this case, what you will do, you will try to minimize the cubes which have blue and green colors on them, right? Because third color is red. If you paint all the cubes which have blue and green colors on them with red color, then you will find the all 3 colors on the cubes. So when you make the cases, you will find that will occur when the blue and green are on the adjacent walls. Okay, similarly this is green and this backward wall is green, and this red color is on opposite side, opposite face, right? So the minimum possible number of smaller cubes. So this blue and green, it occurs here on this edge, right? Similarly on this edge. But you have to add all the cubes which have all 3 colors available on them already, okay, and all the cubes with blue and green colors on them, because when you paint these colors as red, then all 3 colors are already available on these cubes, and when you paint it red, then this 2 colored cube will be converted into 3 colored cube, right? So for B plus G, first take the all 3 colors. All 3 colors occur on the corners, right? So for this corner, this already have all the 3 colors. Similarly, this corner have all the 3 colors. Again, this corner have all the colors, all 3 colors, and this corners also have all the 3 colors. There are 4 such cubes possible in this case. And for blue plus green, you will find is only these 2 edges have blue and green on them, right? All the other edges, when you check, you will find either blue blue, green green, or red green or blue green combination, right? So 4 cubes available here and 4 cubes here, because the all 3 cubes you have already counted, right? So 8 cubes are colored with blue and green. So there are total of 12 cubes. The required answer is option B. Move to the next question. The number of smaller cubes that have exactly one color on them cannot be more than, right? In this question you have to maximize the cubes having one color. So when you check, you will find this will occur when the faces with the same color are adjacent to each other, right? Because in this case you will find the face cubes also with only one color, right? And the cubes on edges also with the one color only, right? So if I consider red here, red will be here. Next let us take green on the back wall, so green on the upward, blue on the side wall and blue on the bottom face, right? So consider the face cubes only. So on one particular face you will find this 4 into 4, 16 cubes in total, and there are 6 faces. Hence there are 96 cubes on the faces which have the single color, and in this 96 I will add those cubes on the edges which have only one color, right? So I will find the same color on the edges, on this edge red and red, again in blue and blue, right? And green and green, right? So neglecting the cube on the corners, I will get 4 cubes each on the edges. So this will total to 96 plus 12, that is 108 cubes. Hence option A is the answer.